what is the value of refractive index of a given medium? Whereas the Young's double slit experiment is first performed in air and then in a medium other than air. It's found that eighth bright fringe in a medium lies where fifth dark fringe lies in air. So here let us take lambda as a wavelength and mu as a refractive index and d is the fringe width and capital D is the distance between slit to the screen. So it's given in the question that eighth bright fringe in a medium lies in the same area where the fifth dark fringe lies in a air. So in a different medium, we know that lambda will get differ. So lambda in a medium will be equal to lambda air divided by my refractive index. And it's known that the position of fifth dark fringe, or else we can say the position of dark fringe can be written as 2n minus 1 lambda d divided by 2d. So here we are saying, so in the question it's given that fifth fringe is the darkest. So here we can write m as 5. So y, the position of dark fringe will be equal to 9 lambda d divided by 2d. So this is our dark fringe value. Similarly, for a bright fringe in a medium, we can write y, the position will be equal to n lambda dash d divided by d. It's known that lambda is representing the original wavelength, whereas lambda dash is representing the value of wavelength in a medium. It can be written as lambda air divided by mu. So here it's given in the question, we are having 8th fringe as a bright fringe. So n will be equal to 8. So the position can be written as 8 times lambda divided by mu times d divided by d. It will be equal to 8 lambda d divided by mu. So here we have a position of 8th fringe as well as 5th fringe. It's given that they are in the same surface area. So here we can write 8 lambda d divided by mu d will be equal to 9 lambda d divided by 2. When we are simplifying this, we will get mu is equal 1.78. So the correct answer for the question is option C here.